Human activity is triggering earthquakes in unexpected places. Human-driven activities like oil and gas extraction are destabilizing long-dormant fault lines in regions previously considered earthquake-safe. A new study reveals that even geologically stable areas are vulnerable to induced seismicity, challenging traditional earthquake physics and raising concerns about infrastructure unprepared for tremors. The unexpected risk of stable faults for years. It was believed that inactive faults in regions far from tectonic plate boundaries were too weak to cause significant earthquakes. These faults, often found in places like the Netherlands, India's Deccan Plateau, and parts of the U.S. Oklahoma, were thought to have healed over millions of years, forming strong bonds and minimizing the risk of sudden slips. However, research led by Ilona van Dinther of Utrecht University demonstrates that these seemingly stable faults actually accumulate strength over time through a process called frictional healing. The longer they remain locked, the stronger they become, creating a dangerous buildup of potential energy. How human actions trigger shakes human activities, such as gas extraction, mining, dam construction, and geothermal energy production, can disrupt this delicate balance. The sudden stress introduced by these operations overwhelms the accumulated strength of the faults, causing them to rupture in a way that releases far more energy than expected. The 2012 magnitude 3.6 earthquake in the Dutch village of Huizinge serves as a stark example. Triggered by gas extraction in the Groningen field, it was the worst induced quake in Dutch history, forcing authorities to halt extraction operations. The science behind the Shakes Van Dinther's team used computer simulations to demonstrate that, after millions of years of inactivity, even slightly disturbing these faults can lead to a catastrophic release of built-up strength. The simulations show that after roughly 35 years of stress, the fault gives way, triggering an induced earthquake larger than anticipated. Once the strength is released, the fault becomes dormant for millions of years, but the risk remains. With thousands of these healing faults scattered across stable regions, continued human activity could trigger multiple tremors over time. Implications and precautions. The proximity of these shallow faults to the surface means that even moderate quakes can cause significant shaking, particularly in areas where infrastructure isn't designed to withstand such events. Daniel Faulkner, a geophysicist at the University of Liverpool, emphasizes that companies developing projects in these regions must understand the underlying risks. Even as the world transitions to clean energy, geothermal projects, which also induce seismicity, will continue to rely on accessing Earth's surface, necessitating careful planning. Van Dinther suggests that developers should prioritize slow, controlled extraction methods to minimize sudden stress on faults. However, the key takeaway is transparency. Developers must acknowledge and communicate the potential for earthquakes to affected communities. We should account for the effect of healing and strengthening in hazard assessment. Van Dinther concludes, underscoring the need for updated risk evaluations in previously stable regions.